Hi, everyone. Welcome back to our 15th round of the Crowdcast series. Super excited to have been doing this for so many different months now. I see that a lot of people have already submitted questions in the chat where the comments are. Just sort of as a reminder, typically I choose the questions from the Ask a Question section. So if you do want to ask a question ahead of time, please enter it in that section. I do see a lot of great questions in the comments section, which I typically use during the live chat to answer questions like live. So please resubmit your questions that you have here in this chat, because I will not be able to get to all those that have already been put on the chat section. Please resubmit them for next month's Crowdcast. I do see a lot of great questions there. So just a couple of more pieces of information before we jump right in. For those of you that are attending live, remember you can see a replay of this Crowdcast Q&A. Access it on your dashboard. So that would be at foundmyfitness.com/dashboard. And you can replay the YouTube video, or you can also listen to the audio only version of this Q&A. And that can be found also on your dashboard, which will give you a link to a private podcast feed. And the private podcast feed contains our Q&As. It contains our recent Aliquot episodes, and as well as other episodes that we will be pre-releasing early on our on our members feed. So again, everything you can access on the FoundMyFitness member dashboard. Also, just as a reminder, these Q&As are me sort of doing some scholarly work in the scientific literature. They're not intended to be medical advice in any way, shape, or form. This is not a patient-client relationship. I am a scientist, not a medical physician. So please, any types of lifestyle changes you're going to make, run anything by your doctor, and just keep in mind that I'm just really helping sift through some of the scientific literature and providing sort of my thoughts and comments on things. All right, so I'm going to go ahead and jump right in. For those of you that this is your first time, typically what I do is I pre-select some questions ahead of time. I look at a variety of different things, the top voted questions, as well as questions that have never been covered before. I feel like that is important. Also questions that I've had multiple times, which I think more people are going to be interested in. And also I archive all the questions. And as I mentioned last Q&A, I do go back and pull from old questions as well. But feel free, if your question did not get covered, you can submit it again the next time around if you would like. But again, I do also go back to old questions. So the first question is one of the top voted questions, and it's something that I actually have. I have received this question many times. This question was I've received it in some shape or form many times. This question was submitted by Caitlin, and Caitlin asks, is there evidence to support eating organic produce and meat compared to non-organic products? I have also been seeing conflicting reports on the pesticide glyphosate and whether or not it is safe to consume at the levels that are present in some of the foods we buy and eat. So is glyphosate safe, particularly in certain populations? Any comments are appreciated. So there's multiple parts to this question. We're going to start out with the eating organic produce compared to non-organic produce. We'll also cover organic animal products as well. There are really two major factors when evaluating organic food. There's nutrition value, and then there's the safety aspect. So I think we're going to start with the safety aspect and then sort of dive into some of the nutritional value, and then we'll get into the glyphosate. So first of all, what is organic? In the US, it really means that crops have to be grown without the use of any sort of synthetic pesticide or bioengineered genes or petroleum-based fertilizers, or even sewage or sludge-based fertilizers. So that's for produce. As for animal products or meat, it means that animals are raised in living conditions that accommodate their natural behaviors. So, for example, grazing, pasture raised, being able to graze on a pasture. They are fed 100% organic feed and forage, and they are not administered any types of antibiotics or hormones. Okay, so let's start with the safety. And it's really a nuanced question because there's not any long-term randomized placebo-controlled trials comparing health outcomes between organic diet versus a conventional or non-organic diet. So basically the best data that we have in terms of health outcomes, people that are getting, for example, let's say cancer or neurodegenerative diseases, they all come from observational studies, which of course are riddled with all sorts of problems because you can never establish causation. It's really just a little piece of, the larger body of evidence when you're trying to analyze something. Observational studies can't be the only evidence to make a claim. So with that said, what the observational data has shown is that increased intake of organic foods is associated with a reduced infertility rate. It's associated with reduced birth defects. It's associated with reduced allergies. It's associated with reduced preeclampsia, reduced metabolic syndrome, BMI, and also reduced incidence of non-Hodgkin lymphoma. But again, because these are observational studies, there are confounding variables. So obviously someone who is more aware or that's more likely to eat organic is probably also exercising. They're probably avoiding refined sugars. And to some degree, a lot of these observational studies try to adjust the data for potential confounding factors, but you just can never get them all, right? So that's something to sort of keep in mind and take that data with a really big grain of salt. And also because, these are health outcomes, those sorts of health outcomes like, lymphoma, non-Hodgkin lymphoma, metabolic syndrome, those things take a long time to develop. And so proxies or biomarkers are often used as in the field, this field with pesticide contamination. One proxy is actual pesticide metabolites in urine. So looking at, metabolites of pesticides is another way to sort of gauge the exposure to pesticides. And so there have, of course, been studies that have shown that eating organic produce is associated with less urinary metabolites of pesticides. I mean, that's sort of a no-brainer. Looking at the type of produce that are exposed to pesticides are also important because some types of produce are really, the pesticides aren't really taken in quite as much. And so every year, the Environmental Working Group has created a list of produce with the highest levels of contamination, and those with those are called the dirty dozen, and then the produce with the lowest contamination, those are really called the clean 15. This year's dirty dozen includes, and they're pretty similar, I would say, from year to year, but this year includes strawberries, spinach, kale, nectarines, apples, grapes, peaches, cherries, pears, tomatoes, celery, potatoes. So going organic for those may be more ideal because those types of produce take in more pesticides. And I think this really helps for people that are on more of a budget, because organic produce can oftentimes cost substantially more. The clean 15 list, or in other words, the produce that does not absorb as much pesticides this year, includes avocados, sweet corn, pineapple, onions, papaya, sweet peas, eggplants, asparagus, cauliflower, cantaloupe, broccoli, mushrooms, cabbage, honeydew, melon, and kiwi. So those foods are in terms of, basically, they don't have as big of difference in terms of how much pesticides are in them compared to actual organic produce. So that's sort of something that's important to keep in mind. Another kind of piece of data that's interesting is that there was a meta-analysis that found that organic food actually has less contamination with the heavy metal cadmium. This is not true for all heavy metals. For example, there was no difference in arsenic or lead between organic and non-organic produce, but there was a difference in cadmium. So that is also something to keep in mind. For me, one of the biggest factors that sort of pushed me over the edge to really eat organic, and again, we're talking about produce still, was the increased risk for Parkinson's disease. And a lot of, Parkinson's disease is a neurodegenerative disease that affects the dopamine producing neurons in a region of the brain called the substantia nigra, which is, basically a very important region for motor control. And one of the probably most informative early pieces of evidence was from the fact that you could take this sort of pesticide and you could make a Parkinson's disease model in animals. And then, of course, there have been a variety of studies showing that farmers are much, much more prone to Parkinson's disease. And basically, there's this whole Parkinson's disease model where you take something that's called MPTP, and it basically is able to inhibit mitochondria, which are really important for neurons. And this causes an energy crisis and dysfunction, and basically causes the degradation of dopamine producing neurons. Well, this MPTP, the same mechanism is used to basically become toxic to mitochondria from pesticides, insecticides, pesticides, and also pesticides, which are fish-killing chemicals. And so these things are used in agriculture, they're used in home gardening, and it's really, like I said, when given to animals, it recapitulates Parkinson's disease pathology and the features. So rotenone is actually considered an organic pesticide, even though, so sometimes you can have something that's technically called organic, but it's actually has an organic pesticides. That's also something to keep in mind. Paraquat is another one that's really sort of very widely used as an herbicide, and it's been banned in the European Union since 2007. In the United States, it's really limited to very restrictive use. So you have to be authorized to use it. And I'm not sure exactly who's authorized to use it, but paraquat is something that crosses the blood-brain barrier. It's taken up by dopaminergic neurons, causes mitochondrial toxicity, and meta-analyses have found it to be linked to a twofold increased risk for Parkinson's disease. Again, many of these studies are the increased risk are found in people working in agriculture, people that are exposed to extremely high levels. So how much of that can actually translate to the general population is unclear. But what is clear is that high levels of exposure are associated with an increased risk, and they certainly are so shown to cause established causality in animal studies. So that's something that, particularly for people that may have a high genetic risk for Parkinson's disease, or maybe some sort of gene environmental interaction there, that also is a little bit concerning. So So that's sort of the safety button, and let's go on to the nutritional aspect of these organic versus non-organic foods. So organic produce or organic, plants and fruit, so fruits and vegetables have been shown to have higher concentrations of polyphenols, flavonoids, vitamin C. One of the major reasons for that is because when insects or stress in general is imposed upon the plant, they produce more flavonoids, they produce more polyphenols. Like that's the way they're warding off the insect. And so so you actually get produce that have higher levels of these beneficial compounds, these flavonoids and polyphenols, things like resveratrol, like pterostilbene, anthocyanins, all that stuff. So there was one meta-analysis of 343 separate studies that found that organic foods have increased concentrations of phenolic acids by 19%, of flavonoids by 69%, of stilbenes by 28%, and flavones and flavonols 50%, anthocyanins by 51%. I mean, just to me, that also in and of itself is incentive to buy organic, because part of the reason I eat some of these plants is for these flavonols, these anthocyanins, these stilbenes. These things all have been shown to have beneficial effects, including randomized controlled trials in humans. So so that's something that I think is important to keep in mind. Again, for people that are on more of a budget, though, I think the most important thing would be safety first, and looking at the list of produce that really seems to be safer, even if it's non-organic, and then sort of focus on things like apples, strawberries. Like if you want to eat those, it would be better to buy organic. Animal products. So there have also been some studies looking at, pasture raised. So, looking at milk or eggs or beef that is produced from animals that are pasture raised and fed, like they're not eating a bunch of corn and stuff. They have, and their meat has a higher omega-3 to omega-6 ratio, which is desirable. And also, like eggs, for example, from pasture raised chickens have higher levels of lutein, which is a really beneficial compound that's also highly concentrated in green plants, particularly kale and chard. It's important for brain function, for eye function. So that's sort of, one reason why it might be beneficial to consume animal products that are organically raised, pasture raised. Let's shift gears. So that this was, like I said, this was a really, really large question, a sort of loaded question. And so I want to talk about the glyphosate. And, this is a question I've been asked probably over 100 times, probably more than that. But, and I've sort of shied away from it because it's so nuanced when you really only have these observational studies to go off of. And, it's just really hard to make any conclusions, based off of just one sort of piece of evidence. But let's talk a little bit about glyphosate. So there's, data out there showing that it's harmful, and there's an equal amount of data out there showing that it's not harmful. So again, it's one of those, like, what's going on here, right? It's an herbicide. So it basically works by inhibiting phenylalanine, tyrosine, and tryptophan through something called the shikimate pathway. And the shikimate pathway is only found in plants and microorganisms. It is not in mammals. So because of that, glyphosate is considered an herbicide and not a pesticide. So studies that have shown negative health outcomes with the herbicide glyphosate have really, it's been the non-Hodgkin's lymphoma. That's been the real big one. And it's almost exclusively found in farmers that have had high exposure compared to actual consumers. So there's really actually no consensus in terms of what the exposure safety threshold is for glyphosate. So the US has set the acceptable daily intake of glyphosate to 1.75 milligrams per kilogram body weight per day, while the European Union has set it much lower at 0.5 milligrams per kilogram body weight per day. So that's really a big difference there, 1.75 milligrams per kilogram body weight versus 0.5. Personally, I like to go with the lower level. Why there's such a big difference between the European Union and the United States. Probably some sort of bureaucracy stuff that I just don't understand or don't have information about. But there's also been, again, like I said, there's been a lot of variation in terms of the publications in the scientific literature. And part of the reason for that is because a lot of times herbicides also have other insecticides and other compounds that basically there's a formulation there, and you can't just isolate the formulation to the glyphosate. So basically you could have, for example, there's 5 different salts of glyphosate, and each of these are containing different surfactants on them, and the surfactants also have an effect. And so it's kind of like, well, what's causing the problems here? So it's really difficult to tease apart all these little nuances in general. So I would say that it doesn't seem like there's a lot of strong evidence that there's enormous health risks for glyphosate for consumers that are exposed to low levels. But there's also not strong evidence to sort of figure out what the safety threshold should be. So it's sort of like we're walking around in the dark here. That's kind of how I feel. And anytime, what I do in my personal life, when I feel like I'm walking around in the dark, I sort of take the safety aspect of it. And I said, okay, well, I'm just going to try to limit my exposure because we don't really know what's going on. But I'm not going to make a strong claim and say I'm limiting my exposure because it's going to give me X. There's just no real evidence for consumers that it is going to give you X. But again, I just feel like that we're lacking good data here. So I'm just looking in the chat real quick to see if anyone was commenting on any of the pesticide stuff. So I'm going to move on to the next question, which has to do with vitamin D. And the question is, so someone on the screen, sorry, before I get to the vitamin D, Alan is asking, are you saying that organic pesticides are safe? Alan, I was not referring to whether or not they were safe. I was saying basically you can have something labeled organic and it actually have a pesticide that's considered, it's a natural product, so it's considered organic pesticide. It's not synthetic. It's not something that's put together or made. And so in the case of rotenone, I think it's clear that's not safe. So there are organic pesticides and that's where it sort of gets really sort of, I feel like it's, it's sort of disingenuous in a way where you have things labeled as organic, but it actually does contain a pesticide. So basically, I think all uses of rotenone have now been phased out in the United States. But for a long time, it was used and it was considered organic. So no, I do not consider an organic pesticide safe. So the vitamin D question is basically from Joe, and he asked, can you speak to whether disease states decrease vitamin D levels? How do we know it's the chicken or the egg? Meaning, if you're sick, then is that causing a decrease in vitamin D and that's why you have low vitamin D levels, or do low vitamin D levels, lead to sickness? And, the answer is sort of both. Not a lot of diseases do cause a decrease in vitamin D. Things that affect the kidneys and the liver are particularly troublesome because those organs are needed to actually convert vitamin D3 into the metabolites and essentially pre-hormone and the hormone that has all the biological activity. But we know from randomized control trials, and randomized control trials are often there's a lot of nuances and problems with randomized control trials. For example, not giving a high enough dose of vitamin D, not measuring levels of vitamin D at baseline or after treatment to know whether or not you're starting out with someone who's deficient and then giving them a sufficient amount of vitamin D to raise them to a sufficient level. All these things, the randomized controlled trials out there are very heterogeneous in terms of all the things that are measured. And that is a big problem because you could have someone starting out at a normal level with vitamin D. And if you never measured that to begin with, and then you gave them a supplement and they were already at a normal level, then maybe you're not going to see any sort of effect, right? This is the classical problem with randomized controlled trials in nutrition. And I call it nutrition. Vitamin D is something that is usually made in the skin from exposure to UVB radiation from the sun. But it's also found in very, very modest amounts in some foods like oily fish. And of course, it's now fortified in some foods as well. But the fortified versions are vitamin D2. And in fact, I'm now finding out that a lot of controlled trials and prescription vitamin D is the D2 form. And the vitamin D2 form, which is the form that's found in, for example, mushrooms, plants, there's problems with that. There's all sorts of problems with it actually even interfering with the actual active hormone. So that's actually a problem as well with some of these controlled trials, the source of vitamin D, and also magnesium status. Magnesium is a essential micronutrient. It is obtained from the diet. It's, almost half the country in the United States doesn't get adequate levels. It's a cofactor for over 300 different metabolic chemical reactions going on inside your cells, including the synthesis of the vitamin D metabolites, the vitamin D pre-hormone and hormone. And so without sufficient magnesium levels, people can take a vitamin D3 supplement and it will not be converted into the proper metabolites to be converted into the hormone. So lots of problems with even randomized controlled trials. And my point here is that there is a lot of heterogeneity, meaning there's a lot of positive and negative data with the randomized controlled trials with respect to vitamin D. And those are a lot of the reasons why. With that said, you will find positive results with, for example, particularly with certain things where vitamin D is shown to play a very strong role, like respiratory diseases. There's been 25 randomized controlled trials showing that supplementation with vitamin D3 can reduce respiratory disease incidence by 10% and by over 50% in people that start out with low levels. So the 10% reduction is in people that just already have normal levels. And still on top of that, it reduced their respiratory disease incidence even further. And so that's, again, the randomized controlled trials where vitamin D is shown to have a stronger effect, you're going to have more robust results. And you're going to have more robust results in starting out with a population that's more deficient, giving them the supplement, and then, giving them an adequate dose that's going to raise their levels high enough to have an effect. All important factors. The other piece of strong evidence that low vitamin D plays a causal role in disease is from what are called Mendelian randomization studies. And basically, I love Mendelian randomization studies because what they are is they're basically taking people. We have a variety of genes in that are in the vitamin D pathway that are involved in converting vitamin D3 to the pre-hormone, to the active hormone, right? And there's single nucleotide polymorphism, SNPs, in even just, one nucleotide of DNA that can change the function of these SNPs. And they can make them less active or more active. Most of the time, there's a lot of problems with less active. And so you can take people that have these variations in these genes that make them less active, and you can then look at their disease incidence, their disease risk. And it's essentially these people that have less active genes in the vitamin D pathways, a variety of them, they're known to have lower circulating levels of 25 hydroxy vitamin D3, which is the major metabolite that's measured anytime you go get a vitamin D test, right? Blood test. That's what's measured. So it's known that those people with these SNPs have lower levels. And so what you do is you take all these people, and rather than measuring their vitamin D levels, which a lot of people argue, oh, well, people with low vitamin D levels aren't getting outside as much, they're not exercising in the sun as much, they're not taking, the supplements, they're generally not healthy, or maybe they're sick, right? What you're doing is you're getting rid of all that noise, all that, BS, potential confounding factors, and you're just looking at their genes that lead to low levels of vitamin D. And then you're saying, how many of these people get respiratory tract infections? How many of these people die from cancer? How many of these people die earlier? And guess what? People with a vitamin D SNPs that lower their activity, which is known to cause lower levels of vitamin D, that's been shown in these people separately, they have a higher incidence of mortality from all respiratory tract infections. They have a higher all-cause mortality, meaning they die earlier. They have a higher cancer-related mortality. They don't have any higher cardiovascular rate of mortality. Vitamin D is not been shown to play a major role in cardiovascular health. So I find Mendelian randomization studies very informative. And anytime I hear someone tell me, oh, low vitamin D is just a consequence of being sick, what I say to them is, show me the evidence. So we're actually putting together a vitamin D topic page, and we're going to go into the very specific and rare instances where vitamin D levels drop from sickness. And we're going to talk about all this, but I hope that sort of helped clear up some of the confusion there. Linnell is asking in the chat, is there a particular time of day that is optimal to take vitamin D and vitamin K2? So, I've heard a lot of anecdotal data from people. Vitamin D usually is made from the sun, and that is usually earlier in the day, right? There's all sorts of nuance there, where maybe it is better to take it earlier in the day than rather at night. I actually take mine at night because I take all my vitamins right after I eat dinner, just because I'm doing I'm a mom, I'm doing a million things in the morning, and so I have no problem with my sleep. But so I don't really know that there really is an optimal time. And with respect to vitamin K2, same goes there. I'm not sure that it really, matters, to be quite honest. I typically take around 50 micrograms of vitamin K2 present as MK4, menaquinone MK4 is what I'm taking right now. Also, someone's asking in the chat about different vitamin D levels in Europe or Canada versus the US. So the units are different. In the United States, the units are measured in nanograms per milliliter. Nanograms per milliliter. In Europe and in Canada, they're measured in nanomoles per liter. And so it's not that there's different optimal levels in the US versus European and Canada, but it's that the units are different. So it looks like there's different levels. And so basically, in order to get nanograms per milliliter, you have to divide nanomoles per liter by 2.5. So let's say you're in Europe and you had your vitamin D3 levels tested, which would be 25 hydroxyvitamin D, and you came out 100. That's 100 nanomoles per liter. To convert that to nanograms per milliliter, which is what I usually talk about when I'm talking about optimal levels between 40 and 60 nanograms per milliliter, you would have to divide that by 2.5. So just keep that in mind. That it's not that there's different levels for optimal, it's that their units are different, and so you have to convert the units. There's also a question in the chat talking about osteoporosis. I think that, and we'll get to this when we talk about dairy and calcium, but basically some of the major things that are important for maintaining healthy bone status are vitamin D. I think vitamin K2 is increasingly being shown that, because what vitamin K2 does is so vitamin D increases the absorption of dietary calcium anywhere between 40 to 60% higher absorption. So people can be getting all the calcium, they could be taking calcium supplements, but if they're vitamin D deficient, there's going to be problems in terms of getting that calcium, absorbing it, and then problems getting it to your bones and to other tissues like muscle where it's needed, which is where vitamin K2 comes into play. Vitamin K2 plays an important role in activating proteins like osteocalcin, matrix GLA protein. These proteins are involved in shuttling calcium out of the bloodstream and bringing it to the bones, to the muscle. So it's sort of a twofold benefit there. One, you're getting calcium out of the bloodstream where it can easily form a precipitate in the presence of phosphorus. Calcium plaque buildup in the arteries is obviously associated with negative cardiovascular outcomes. So getting that calcium out is a good thing, and getting it to where it should be going, bones, muscle tissue. Calcium is a cofactor for a lot of enzymes, much like magnesium is also very important for tissue function, for bone health. So I think those are important things. Really, exercise also is very important for the maintenance of healthy bones. So just keep that in mind. That it doesn't all come down to calcium. All right, so I'm going to move on to the next question, which was submitted from Michael. Michael asks, I was wondering what Rhonda thinks and what the science says about high intensity IR lamps like 660 nanometers and 850 nanometers for general health. So basically, these high intensity IR lamps work by a concept called photobiomodulation. And we're going to have a topic page on this soon-ish. I've already sort of gathered a lot of data together on that. And, there's a lot of early studies. I don't want to talk for hours about this, but, there are a lot of early studies that suggested that photobiomodulation treatment can improve muscle recovery, improve muscle endurance, improve hair growth, wound healing, skin health. But the research is really in the early stages, and marketing has gotten ahead of the research, pure and simple, hands down, for sure. So, there's a lot of studies on animals, which again, as we talk about all the time, translating animal studies to humans is very challenging. Finding the human equivalent dose, etc., is always challenging. There also are small cohorts of trials that have been done, but these trials have been also very riddled with problems, mostly because the wavelength, the dose, the frequency, the whole protocol, there's too much variation. And so you'll find variation in study to study because the dose was different, the frequency, the power was different. And so you get all sorts of mixed results. And again, it's difficult to know what's happening if there's an effect. There needs to be a standardized protocol set. We need to figure out the right wavelength, the right dose, the frequency, the timing, and with respect to, for example, exercise. Those things all need to be figured out. And right now they just haven't been. And so the literature is just all over the place. There's also a lot of variability in terms of how much melanin is in a person's skin. That also affects the outcome. And so there needs to really be larger randomized controlled trials to help understand all these different parameters. So, and also not only that, also like a lot of the studies have shown that there's a positive effect if you directly apply the laser to the skin. And a lot of the commercially available products are something you like stand in front of or you don't apply to the skin. Now, in some cases, maybe, the power can make up for that. So you have more, let's say you have more power, then perhaps that could, help compensate for that. But it's just really hard without the actual empirical evidence. There's also been a really big placebo effect with these things, and placebo effect, with pain, and like there's meta-analyses you can find. For example, people with rheumatoid arthritis pain, and they do these lasers, these red therapy, and then they're given a placebo laser, which is really good because the placebo laser is very important. The person thinks they're getting a treatment, and it sort of controls for that placebo effect. And so you can find studies where they find people with rheumatoid arthritis have like a 70% reduction in their pain scale compared to people given the placebo laser, right? But when you then dive deeper into those studies and you look at studies where people were given a treatment laser on one hand and a placebo laser on the other hand, that basically they found there was equal pain reduction in both hands, meaning there certainly seems to be a placebo effect happening. So I think that it's really hard to say for sure. I think that there is some increasing stronger evidence with some types of photobiomodulation. But I do think the marketing has gotten way ahead of the actual scientific research. There are some products out there like the Juve, which they do have, third-party testing, measuring their power output and everything. And they seem to have a pretty good power output, which again may help make up for some of the shortcomings where you're finding, the lasers are being, there's LED versus lasers. There are all sorts of nuances here. But, I think that it's certainly possible that there are some beneficial effects that could be used from commercially available products that are very high quality. However, I do think that a lot of those commercial available products, even the ones that are high quality, overstate the health benefits. So looking at the chat, there's a couple of questions straggling along about the vitamin D topic. Bryn is asking, how do you get vitamin D serum levels to an ideal range? So typically, if you are supplementing, generally speaking, 1,000 IUs of vitamin D3 generally raise serum levels of 25 hydroxy vitamin D3 anywhere between 5 to 10 nanograms per milliliter. People have these SNPs I mentioned where they basically do that less efficiently. And I've known now several people, several actually friends and colleagues of mine that have had to take extremely high levels of vitamin D3 to raise their serum levels up to 50, between 40 to 60, around 50 nanograms per milliliter. But again, those are people with vitamin D related SNPs. For those of you that have done a consumer available genetic tests like 23andMe or Ancestry DNA, make sure you use our genetic tool. So you have free reruns on our genetic report. We basically give information on a large percentage of vitamin D related SNPs that are measured by those consumer available tests. We give the information in terms of what the scientific literature says they mean, et cetera, et cetera. So make sure you do that if you haven't already. Corey Gardner is asking in our vitamin D topic page if we're going to address the relationship between vitamin K2, vitamin A, and vitamin E. Corey, we're going to address anything that has empirical, hard evidence, anything with actual data and not a hypothesis, which there's a big hypothesis out there with the vitamin A and all this, yada, yada. And I just, anything that actually has data, we will address. And Elle is also saying family tree DNA also works for our genetic report. Thanks, Elle. All right, let's move on to the next question. This is sort of, this actually probably is more of a rapid fire question, but let's address it now anyway. So this question was from Ron, and Ron asks, does spreading the protein intake along the day have significant improvement in muscle mass comparing to eating it all in one meal? If you look at meta-analyses, pulling lots of data, so there's one that's pulled 23 different studies together, and they found basically that consuming a single bolus of protein either 1 hour before or 1 hour after a workout, compared to taking a single bolus of protein at any time during the day, there is no effect on muscle mass. So they all have the same effect, basically. No difference, I should say, no difference in their effects on muscle mass. Another study showed that it didn't matter whether or not protein was consumed immediately before workout or splitting it up before a workout and 5 hours after a workout. Again, no difference in their effects. So they're essentially having the same effect. And then there was another study that showed that there was no difference in strength, power, or body composition changes, whether or not protein was consumed immediately before or after a workout or spread out among morning and an evening dose. So basically, the answer seems to be, according to the scientific literature, no, it does not matter if you eat all your protein in one meal or you spread it out throughout the day with respect to muscle mass. Ken is asking in the chat about there being so many different types of magnesium and if there's a real difference in the bioavailability, I guess. I would say probably the biggest difference that I've seen, generally speaking, not a huge difference between the organic acids, so like magnesium citrate, magnesium malate, magnesium, what are the other common, organic acid ones? Those seem to be very similar in terms of their bioavailability. The one that's really seems to have a lower bioavailability is magnesium oxide. And also magnesium doses higher than around 125 milligrams. As you start to get higher than that, then bioavailability goes down. And so you're essentially just having more of a, effect on the gut, essentially. So, taking really large doses of magnesium, all at once, when it's supplemental, when it's not with food, may be different. Magnesium glycinate is a good bioavailable source as well. So I would think that, I mean, that's typically what I take I take magnesium glycinate. Also, I'll take magnesium malate as well. The other thing I take, let me see. So I do a lot of, it's important to keep in mind that people that are very active in sweat, magnesium can be excreted through sweat glands. And sodium is one of the major things that's excreted, but magnesium is also excreted. And people that are very athletic and people that are using the sauna a lot, like myself, you do excrete magnesium, and so people can require anywhere between 10 to 20% more than the RDA in terms of people that are extremely athletic. So I take this magnesium easy sticks. I like it. It's got 150 milligrams of magnesium malate. And these are from Pure Encapsulations. I don't have any affiliation with them. They also have some blueberry powder in it. And so it's like it comes in a little stick, and I open it after I do my exercise in sauna, dump it in my mouth, and then I drink some water. So I really like that. But I also get a lot of my magnesium from my food. And I also at night will take magnesium glycinate. And it's like, I think it's somewhere like 130 milligrams or something like that. It is better if you are supplementing with multiple doses of magnesium to spread it out in terms of absorption. And people that are taking, we've covered this in a previous crowdcast, supplemental magnesium for migraine headaches. There is evidence that taking around anywhere between I think it was 500, maybe it was 600 milligrams of magnesium can help with migraines, at least in several different randomized placebo-controlled trials. So that is something also to consider. All right. Let's move on to the next question, which is also a very, very big question. And it's also a question that I've been asked hundreds of times. And we're probably going to somehow cover this in a topic article. And it's just a big beast to cover. And it's basically related to dairy. So there's two specific questions this time around with dairy, but in general, people are just asking, these questions were from Iman and Emily, and they were asking if dairy products have negative health effects. Is it generally healthy to consume? If you are lactose tolerant, does it increase the disease risk for various diseases? So without specifically reading all the questions, the general gist is like, is it safe to eat dairy? And I think that I'm happy that someone brought up the lactose tolerant part, because there's a huge population of people that is lactose intolerant. And in fact, the lactase gene, that's usually, it's usually switched on early in infancy, so that infants can drink milk and stuff without a problem, and then later on in life it can be sort of switched off, where people can become lactose intolerant. And 75% of African Americans are actually lactose intolerant, which is a big problem. And if you look at some of the data with like dairy consumption, there also seems to be a really negative effect with some of those populations. Also, the fact that one of the major consumer products, which is vitamin D fortified, is milk, and African Americans are much more prone to vitamin D3 deficiency because of their melanin concentration. And so there's been studies that have shown that they have to stay out in the sun 6 to 10 times longer to make the same amount of vitamin D3 as a Caucasian person. And, you know, our modern day life, you know, is very different than it was, you know, hundreds of years ago when we were outside farming, we were outside hunting and gathering. We were, you know, we weren't inside in a cubicle. And when we were outside, we weren't wearing sunscreen and all this clothing. So, you know, times have changed. Also, people have migrated to more northern latitudes. You know, so if you have someone with darker skin, they're more adapted to be closer to the equator. Melanin is an adaptation to protect you from getting skin cancer. And so because, you know, you're out in the sun more, it really helps. But when you take a person with darker skin and they move to, say, Chicago, you know, it could be a problem because UVB radiation doesn't reach the atmosphere as much as it would in, for example, Somalia. You know, so you get a problem of not, you know, basically becoming vitamin D deficient. And of course, the same goes, you can flip that around. You take a light-skinned person from Ireland or, you know, England, and you move them to South Africa or Australia, they're going to have a much higher incidence of skin cancer, melanoma incidence, you know, because they're fair-skinned and don't have that, you know, nice melanin to help protect them from the burning rays of the sun. So anyways, that was a tangent. My point was that I was getting to a point, which was that African Americans that actually are not, that are lactose tolerant, they have higher levels of vitamin D3. That's been shown in studies because they're getting it from the milk. So I thought that was very interesting. And also the fact that we need to find another food to fortify vitamin D3 with so that, you know, people that are lactose intolerant gets, you know, more vitamin D3. But so let's dive into dairy. So first we'll look at all-cause mortality and basically milk and dairy consumption. If you look at all-cause mortality, there seems to be no effect. So it's not higher or lower for all-cause mortality, irrespective of high or low-fat dairy. Cardiovascular disease, these are observational studies. These are, you know, taken with a grain of salt because confounding factors, and, you know, you can't really establish causation. So that's always something to keep in mind. But let's talk about the observational studies. Cardiovascular disease, dairy consumption is associated with a decreased risk of cardiovascular events by up to 16%. So if you look at a lifetime risk of a cardiovascular event in a person is about 30%. So dairy is associated with lowering that risk by about 25%. So it takes you from 30% to 25%. And interestingly, low-fat dairy is associated with reduced blood pressure. But we'll talk about some other problems that are associated with low-fat dairy in a minute. Cancer is a bit of a nuanced story, depending on the type of cancer. So milk, but not cheese, is associated with about a 17 to 38% decreased risk of colorectal cancer. And the lifetime risk of colorectal cancer for any person is about 4%. So milk can reduce that to 3%. So not a really big difference there. And again, this is association. It's not for sure. However, milk and dairy consumption is associated with a 50 to 100% increased lifetime risk of ovarian cancer in women. So the lifetime risk of ovarian cancer in women is about 1.5%. So, you know, it's not huge. So basically, it seems as though dairy can possibly increase that risk from 1.5% lifetime to 2 to 3%. So about double. For breast cancer, there are basically studies showing a modest protective effect of dairy. There are studies showing no effect with dairy, and there are a handful of studies showing a potential increased risk of breast cancer. So really, it seems like the the jury is still out on that. And if there is any relationship between dairy consumption and breast cancer risk, it seems to be very minimal. Dairy consumption and prostate cancer risk is also a little more complicated. So there have been retrospective studies that have found that dairy may increase the risk of prostate cancer in men by up to 100%. But this may be due to bias and basically in their selecting for controls, which influence confounding factors. So there's a lot of problems with a lot of those studies. When you look at prospective studies, there's an association between a 1 to 2% increased risk. The lifetime risk of prostate cancer it varies by race and ethnicity, but it's usually somewhere in the ballpark of about 15%. So if dairy does affect prostate cancer risk, it appears it's only doing it between 1 to 2%. Other modifiable lifestyle factors include obesity, type 2 diabetes, low testosterone. Those things all have been shown to actually have a much more pronounced effect than dairy. Weight gain, there's only seems to be an effect on weight gain if calories are not controlled for. When calories are controlled for, dairy does not affect weight. So it seems to be that, people that are taking in excess calories in the form of dairy, that could affect their weight. But if you're looking at someone that's taking in the same amount of calories, whether it's from dairy or not, then there's really no effect. Type 2 diabetes, sort of mixed data there. There's been some observational studies where there's a dose-dependent effect lowering type 2 diabetes risk. So highest consumers of dairy have between a 10 to 20% decreased risk of having type 2 diabetes. The lifetime risk of type 2 diabetes also varies by race, but it is typically in the ballpark of around 35%. So people with high dairy consumption can lower that risk to about 30% instead of 35%. So there was a recent randomized controlled trial showing there was no effect on biomarkers, of blood glucose levels and stuff. So it's really not clear. Perhaps people that are eating dairy the dairy is replacing, refined sugars or things like that people would be eating. So it's not that the dairy is necessarily protective so much as the dairy is, that people are getting their calories from a source of food that is less likely to impair their insulin response, etc. Bone health, really sort of mixed data, and it possibly because so many people are vitamin D insufficient and deficient. So, you can get studies where, you see dairy can improve bone health or there's no effect. So really, I think it all comes down to whether or not someone is getting enough vitamin D, because you need the vitamin D to absorb the calcium. So I think that's a really big factor there. Brain health is the really interesting one because there's been some studies showing that these are, of course, again, observational. So it's just all of this is kind of like, this is interesting, but it's not like the be all end all kind of thing, right? Because you can't establish causation. There's been associations, mothers that take in higher dairy intake before pregnancy, there's an association with increased brain size in the baby throughout pregnancy. So that piece of information was interesting. The most interesting piece of information has to do with Parkinson's disease risk. There have been prospective studies looking at the correlation between dairy intake and Parkinson's disease. And it's found that basically people that take in higher dairy, like a higher intake of dairy foods, have a increased risk for Parkinson's disease. And this is particularly true in men more than in women. when actually breaking down the type of dairy food, it became clear that there were positive associations found in low-fat dairy, but not in normal fat dairy. So people that were taking in low-fat dairy products had an increased risk for Parkinson's disease. People that are taking in normal, not low-fat, did not have that increased risk. I don't quite understand why that is, but that's what the data says. So in this instance, Parkinson's disease risk increased by 17% for every 200 grams a day increment in low-fat milk intake, and it increased 13% for every 10 grams per day increase in low-fat cheese. This kind of translates to an estimated 2 to 4 Parkinson's disease cases per 100,000 person years for every 200 grams increase. So it's really not exactly known, again, why it's for the low fat, but it would be nice to have some randomized controlled trials looking at that, because it certainly is an interesting finding when it's particularly when you're looking at, you see it for certain types of dairy and not others. So that's pretty much it for dairy. And Jamie L is asking, are these dairy studies confounded with vitamin D fortification? That's a good question. It's certainly possible. I haven't seen anyone correcting for vitamin D levels in any of these studies. So, are you essentially taking a person who would have lower levels of vitamin D and raising their levels up a little bit from the fortification in milk, and therefore they have a beneficial effect? Possibly. The amount of vitamin D in these fortified dairy products is so low, though. I would be surprised if that had a real robust effect, but you certainly can't rule it out. So that was sort of just a sort of the tip of the iceberg on the dairy, without getting into all these mechanisms and things like that, because as I said, we are gathering. I mean, we have like probably 50 pages on dairy right now, the team and I. So we're sort of putting it all together piece by piece. Okay, the next question has to do with lectins. This question was submitted by 0088 Goal, and they ask about the plant paradox by, I guess, Stephen Gundry, and he talks all about the harmful lectins in that book. So there's this topic, of quote unquote anti-nutrients in foods, and it's really gained popularity, and I think for a lot of reasons. But I would say that for the most part, a lot of it is grounded in theory and fear-mongering more than anything. Well, let's talk a little bit about lectins. So both food and bacteria express A and B types of antigens, and these antigens are found everywhere throughout nature. They're more concentrated in certain foods, particularly beans, so legumes. Heat from cooking can destroy them most of the time, also soaking, fermenting them as well. The connection between lectins and, let's say, gut dysfunction, really, it's been just most of the studies that have been done by dumping a high concentration of lectins on cells in culture. I haven't even seen feeding animal studies with lectins showing that it causes gut dysfunction. So you're talking about extrapolating, in vitro cell culture data and saying, yep, this means it's harmful to humans. I haven't even, it's the data is like, it's so not there. And I think that what you may find is that perhaps there are people with gut dysfunction, whether that's from antibiotic overuse, from having inflammatory bowel disease, Crohn's disease, celiac, perhaps C. diff. You may have people that have gut problems that perhaps eating some very concentrated, lectin. So let's say they're eating a big bowl of kidney beans. Maybe there would be an effect in those specific populations. And I think maybe that's where a lot of this is coming from, this anecdotal data from people that have gut issues. That I think seems to like it could be a possibility, just based on knowing, if your gut barrier is sort of broken down already and you're taking in a high concentration of lectins, perhaps immune cells may see these antigens, particularly in the presence of alcohol also. Like, so having alcohol in the mixture can really exacerbate that. So that would be, I think, like my take is that, do I think everyone has to avoid foods with any lectins? Absolutely not. Do I think that people are profiting from making it sound like they have some secret knowledge about lectins that no one else has? Yes. Is there a potential problem in people with, gut dysfunction already? Perhaps, particularly, in foods that are heavily concentrated. Perhaps. I think that seems like a very strong possibility. Next question is from Rachel. Rachel asks, I would love your insights into the most popular consumer available tests on the market. For example, microbiome test by Viome, or biological aging, MyDNAge, or GlycanAge. So let's kind of start at the beginning there with the microbiome test. I think, we're sort of just at the tip of the iceberg with respect to the research on microbiome and how different species of bacteria, how different phyla and species are affecting disease risk, how they're affecting absorption of macronutrients, how they affect absorption and production of micronutrients. We are still in the gathering data phase. I do think that a company like Viome could be useful for looking at your microbiome snapshot. What does your microbiome look at? It might be useful for testing, what happens when I, eat a higher percentage of foods with fermentable source of fiber in them. Do I change the concentration or the quantity of different types of bacteria that are, commensal or good bacteria, or, vice versa? What happens when I cut it all out? Or what happens after I take these antibiotics? So there can be, I think, a lot of useful information that you can, self-experiment with using a Viome test. With respect to doing a Viome test and then looking at the recommendations they give you, I think it's crap. I think it's complete and utter crap. I've had a variety of people tell me, things, and it's just not based in real, good science, where they recommend you change your food based on this, or don't, or avoid something based on that. I think that it's bad. But I do think they do have a reliable testing service, and that they are, if you want to get that raw data to see, the microbiome makeup and how different foods change it, I think that is very interesting. Another good test is the American Gut Project. And they're much, much more scientific and not, they're run by scientists. And in fact, the whole point of the American Gut Project is they're using it for research, the information. So they're much less interested in marketing and trying to sell you a product, and much more interested in the science, which is always good. Not that products are bad. You just, when something's really, really in its infancy, you just have to be careful with, recommendations that are given and stuff like that. So, My DNAge. My DNAge is based on Steve Horvath's epigenetic aging clock. If you haven't checked out our topic page on that, please do. Steve is an acquaintance of mine, great guy, very good scientist. I did an interview with him over a year ago. We are going to release it soon. There's been some sort of hiccups, but I'm really excited to say that we've sort of been instituting some new processes and hiring some new people that are going to really help get our interview series back on track. And the pandemic has also sort of delayed things. But anyways, my point is that you guys are going to learn all about epigenetic aging really soon. If you check out our topic page, please, if you're interested in it, please do. It's a really good topic page on our website. But essentially, the MyDNAge test is good at gauging your actual chronological age. It's a really good marker of chronological age. So I wouldn't use MyDNAge necessarily as a good test for biological age. So Steve, Dr. Steve Horvath has come up with a variety of different epigenetic aging clocks that can be used as a proxy for chronological age, for biological age, for predicting mortality. And so the MyDNAge one is based off his original epigenetic clock, which was really good at predicting chronological age. The clock that he used to predict biological age was developed at UCLA, in Steve's lab with Morgan Levine, who at the time was a postdoc in his lab. She's now moved on and has her own lab somewhere on the East Coast. I forgot which institute. But the biological aging clock was generated by basically not only looking at these epigenetic marks that are on, DNA, but by weighting an average of 10 different clinical characteristics. So looking at chronological age, looking at albumin, creatine, glucose, C-reactive protein, lymphocyte percentage, your mean cell volume, red cell distribution, alkaline phosphatase, and your white blood cell count. And that whole thing, then this phenotypic age clock was generated with a combination of basically figuring out those factors with respect to epigenetic marks. And that is a really good marker of biological age. I know that Elysium, they've teamed up with Morgan Levine. She's a scientific advisor for their company, and they have developed a new biological aging clock test. I believe they call it Index. And I have no affiliation with Elysium, by the way. And I have not used their index yet, although I plan on it. So that has the potential of being potentially a good indicator of biological age. The glycanage is just too early in infancy. I mean, the publications on that are like 10 degrees away from actually being able to measure biological age. It really hasn't even been shown to be a predictor of biological age, whereas the DNA phenoage has been shown in study after study after study after study to be a really good predictor of biological age. So just no comparison. I would say glycanage, like I wouldn't even, consider right now. Okay. The next question was from Carolina. or Carolina. I've heard it pronounced both ways. And it has to do with another quote unquote anti-nutrient called oxalate. Looking at the chat here. Carolina asks, I've become aware of oxalates, compounds in some plants that can accumulate in some tissues in the body and have been linked to conditions like chronic pain, fibromyalgia, interstitial cystitis. First of all, not true, but that's been linked in blog posts probably, but I have not seen scientific literature linking that. What does the research say about limiting consumption? Are there any SNPs associated with being more susceptible to oxaluria? All right, here we go. So oxalate is generated inside the body. It is actually an end product of vitamin C metabolism. So our body is, this isn't an anti-nutrient in the sense that, it's something that you can take it in from plants, but we make oxalates in our body without taking in plants. And guess what? You need vitamin C to survive. Without vitamin C at all, you die. With zero vitamin C, you die. So oxalates are something people like to call them anti-nutrients, but people aren't very educated because an anti-nutrient is something that is, exogenous from the body, something that your body, does not make. It's foreign. Oxalates are made in the body from vitamin C. Anyways, just a little interesting tidbit because everyone calls it an anti-nutrient, but I don't think people have done enough research to figure out that actually we make oxalate in our body. It's not just something that you can get by eating raw spinach. Anyways, so regardless of its source, it is excreted in the urine, and that's because humans lack the oxalate metabolizing enzymes. So dietary oxalates are generally poorly absorbed. Dietary oxalates meaning the ones that you're getting in from food, not the stuff that you're making in your body from vitamin C metabolism. But oxalates are found in many foods, and basically when the oxalate is bound to calcium, it makes the oxalate insoluble. So once it's ingested, calcium in the gut binds to the oxalate in the intestine, and it produces calcium oxalate, which is eliminated in the feces. So it's basically, a non-problem when you have enough calcium there. And by the way, green leafy plants are high in calcium. Oxalates can be found in plants. So like, let's say black tea, which is also high in oxalate. The food that's probably like highest in oxalate would be like raw spinach. Kale is not high in oxalate. Spinach is higher in oxalate. And cooking oxalates, cooking foods can also release the oxalates into the water, and so you basically, you're getting rid of the majority of the oxalates when you actually cook the foods. But again, the calcium is basically making the oxalate insoluble. So you're basically not even absorbing it. It's just going out through your poop. Also, gut microbiome. So the bacteria there's certain species of bacteria in the gut, they actually metabolize the oxalate. And so again, it's not a problem in some respect. So let's talk a little bit more about the absorption from foods. Typically, the absorption of oxalates from food is about 2 to 5%. Now, if you're talking about, so we'll talk about like, if you're looking at like radio-labeled oxalate, there's been studies that have radio-labeled oxalate and found that you can, absorption of oxalate could be, up to like 5 or 6% when consumed with a normal diet. Whereas if you're doing it while fasting, if you're drinking black tea, for example, while fasting, your absorption can kick up to 12% because there's no calcium. The foods have the calcium. things like that. And so the fasting with the black tea can really kick up the absorption of oxalate. And again, restricting calcium can enhance the absorption in general. So basically the occasional, absorbing, oxalate from eating foods like spinach, part of a normal mixed diet where you're not like, consuming just crazy amounts of spinach every single day. I mean, who does that? Like you'll find a few cases in the literature where some person did that, right? And then there was a problem. But just generally speaking, normal amounts from a varied mixed diet, there's really no problem with respect to, having any types of health problems with oxalates. There are certain things that can cause problems, and those are people that have genetic predisposition, fat malabsorption issues, or existing kidney disease. So basically, just to kind of wrap up the absorption from food section, the oxalate, for example, in spinach is insoluble in the presence of calcium and also magnesium ions, and it dramatically decreases the absorption to less than 5%. And basically, in fact, eating large amounts of greens is actually associated with a lower risk of kidney stones. So if it was so bad for the kidneys, then you wouldn't see that correlation. And as I mentioned, cooking also decreases oxalates. But let's talk about these SNPs. So there are, they're rare and they are autosomal recessive, genetic disorders. There's certain genes that people have, AGXT gene, the PH2 gene, the GRHPR gene, the PH3. These things can basically, they're very rare though, but they can cause the problems with oxalate metabolism. There's also fat malabsorption issues. So, for example, people normally when they're eating the oxalate, it's complex with calcium, and so it's difficult to absorb. But people with fat malabsorption issues, the free fat in the colon can bind to the calcium, and so it kind of prevents the calcium from binding to the oxalate, and so you end up getting that effect like you were fasting and drinking black tea essentially, right? So you can increase your oxalate absorption can go up to, twice as much. So patients that have fat malabsorption, you can have oxalate absorption that could be over 30%. So it could be a big problem in people with the fat malabsorption. And actually people with fat malabsorption are often prescribed calcium supplements to eat with their meals so that they can basically decrease their oxalate absorption. As I mentioned, the gut microbiome also plays a role in oxalate metabolism. There's a very specific species of bacteria called Oxalobacteria forminges that is gram-negative and anaerobic, and it's present in the human colon, and it's capable of degrading oxalate. So again, another method that our body has of getting rid of the oxalate, so it's not even going into the kidneys, it's not going through that whole pathway at all. In fact, animal studies have found that just getting normal oxalate from food can be completely eliminated from the intestinal tract with this type of bacteria in the gut or in the colon. There can be problems. People that have had repeated antibiotic use, they basically can have more urinary excretion of oxalate versus it coming through the feces. So the urinary excretion would be indicative of it going through the kidneys, etc. So, and that is because that specific the bacteria has been decreased from the antibiotic use, and so that pathway sort of eliminated. So that can disrupt, the normal oxalate degradation mechanisms. And again, your body has these mechanisms because it makes oxalate. You make oxalates as a byproduct of vitamin C metabolism. So your body has found out a way to get rid of it through the calcium, having calcium and also, bacteria in the gut. Inflammatory bowel disease is another potential disease that can disrupt the oxalate degradation. And that's because the intestinal microbiome is disrupted in people with IBD. So again, you can have oxalate levels much higher in people with IBD. So perhaps people with IBD may want to sort of limit the oxalate, use. That's pretty much what the science says. All the fear mongering that you'll see in the bloggers and the this and the that, I mean, it's just not grounded in science. So there are certain people that can have a risk. I just mentioned who those people are, but generally speaking, it's not a big problem. And I think that a lot of times people will grab some study in the literature where some woman with kidney disease juiced like 1,000 pounds of spinach for every day for like 5 months. Oh, she got a kidney stone. It's like, come on, how relevant is that to us, to the major population? So I probably will cover that topic in a video. Something I got to get that information out because I'm so fed up with hearing. I'm fed up with the just crappy evidence that people are using, to argue that you should be so scared to eat your spinach or eat any greens at all. And particularly when these people tell you that oxalate is something found outside of the body, wrong. You can never eat any green containing foods with oxalates, and guess what? You're going to make some oxalates from the vitamin C metabolism in your body. Anyways, I just love that. I love how people use that argument. They don't know what the heck they're talking about. Okay, I'm going to go to some rapid fire questions here. Justin's asking in the chat, are oxalates more of an issue for those susceptible to kidney stones? I had a stone that was primarily oxalate, but I drank a lot of tea and such throughout my youth. It probably could be more of a problem for people that are susceptible to kidney stones, but not necessarily, again, because of the elimination route through feces that is regulated through gut microbiome, that is regulated through calcium intake. For people that are prone to kidney stones and may have a disrupted gut microbiome and may not be getting calcium or, getting their oxalates from the tea, I would say getting oxalates from black tea is more of an issue because it's not complex with the calcium. And so you end up having that issue where then, you're 100% relying on whatever amount of that bacteria is in your gut to eliminate it through the feces. And if not, it's going to go through the kidneys. And so if you are, susceptible to kidney stones, probably not good to be drinking black tea. Sorry. At least not on a daily basis. So not on a daily basis. Or if you are drinking black tea, get some calcium with it. Okay, rapid fire questions. Alan asks, can antioxidant supplements suppress the benefits of strenuous exercise? When should you take them? How long before or after exercise? Basically, so the answer is dose, timing, mechanism all make a difference here in what we're talking about with antioxidant supplements. So if you're talking about, I would say the strongest data is for high dose alpha tocopherol form of vitamin E, high dose being like 400 IUs a day. Anything in the range of what normal RDA levels are, which is around somewhere like 40 IUs, 25, somewhere between 25 and 40. There doesn't seem to be any effect in terms of impairing benefits of exercise. I would stay away from super high doses, 400 IUs of alpha tocopherol per day. Things that, the levels that you're going to get in a multivitamin or the levels that are in, for example, a fish oil supplement to help prevent oxidation are not really something to be concerned about, in my opinion. In terms of like vitamin C, most of the studies that have shown an impairment on exercise-induced benefits have all been done in combination with high dose alpha tocopherol, vitamin E. There has been one study that was high dose vitamin C taken multiple times per day around the time of exercise that blunted some of the effects, but that's the only one. Other studies showed no effect. So, other things, resveratrol. So vitamin C and vitamin E are direct antioxidants. They are able to bind and sequester reactive oxygen species, which are generated, when you're doing any type of exercise. You're generating a burst of oxidative stress, which acts as signaling molecules to activate all these genetic pathways that are antioxidant, anti-inflammatory. So if you stop that signaling from happening, then you don't get the activation of the genetic pathways, which are just orders of magnitude better than in terms of their antioxidant effects, better than taking, a vitamin E supplement. When I say the mechanism, those are direct antioxidants. Indirect antioxidants can be some things like resveratrol, for example, mostly acts in a very similar way to exercise. It's a different process in a way. I mean, it's through, it's a chemical. I mean, it's a compound that is activating these genetic pathways. But it, so resveratrol has very mild antioxidant capacity. So, possibly if you're taking a high dose of it, around the time of exercise with the resveratrol, it hasn't been all worked out because some studies have shown it enhances exercise-induced benefits. It's possible that the best thing would be, to take the supplements. And it's also another reason why I take my supplements at night, several hours after I've done exercise, because most of the signaling that's done from the oxidative burst, from the inflammatory burst, after a couple of hours, you've activated a lot of those pathways. So I like to take my supplements, a few hours after the exercise rather than, right before. So that's sort of my 2 cents on that. Henry asks, Dr. Bruce Ames, one of your mentors, has spent many years working on what was called the Cori Bar. Will a commercial Cori Bar be released? The Cori Bar was a micronutrient based bar, which had a variety of micronutrients and also DHA, the omega-3 fatty acid, DHA, complex to a fiber matrix. There was we did some controlled trials where there was a beneficial effect in people, lowered a variety of bad lipid biomarkers. It improved, other parameters as well, inflammatory parameters, without changing anything else in the diet. This bar was licensed by a company. The company is called Heal Right. And they are, I believe, now selling the bar. You can find that at healright.com. That's HEALRIGHT.com. I have no affiliation with the company. Bruce hasn't really, kept in touch with exactly what they're doing. They did do a little bit of reformulation to make the bar a little more palatable. But that's pretty much all I know is that it is available from healright.com. And again, I just have no affiliation with them at all. I haven't even tried the new bars. Michael asks, is there a test to look at LDL particle sizes? For example, small dense LDL, triglyceride to HDL, ratio and things like that. I personally, I like the WellnessFX Advanced Heart Health Test. I have no affiliation with WellnessFX. The Advanced Heart test, they basically, it includes the total lipid amounts, and they break it down into lipid particle counts, sizes, patterns. So they're basically looking at all the LDL, HDL sizes, all their particle numbers, and also the patterns like phenotype A, phenotype B I've discussed in previous crowdcasts, as well as total cholesterol, total LDL, HDL, things like that. They also look at other lipid particles like ApoA1, ApoB, LPA, triglycerides, free fatty acids. They also look at omega fatty acids, the omega-3s, as well as omega-6. They look at other markers of inflammation and clotting. So they'll look at high sensitive C-reactive protein, homocysteine, fibrogen, things like that. And so that advanced heart health test from WellnessFX, it's about like $374. And it's direct to consumer. So you basically, you don't need to go through your physician to get the test, but it's not covered by health insurance. You do have to pay out of pocket. But I like that for several reasons. It kind of gives you privacy, but also it's just it's a really great panel for cardiovascular health. Janice asks, if one regularly takes omega-3 supplements, but also gets omega-3 from the diet, like fish, is it advisable to take supplements at a separate time of the day than your dietary consumption? Basically, I take my fish oil every day with no concern about timing when I eat my fish. I don't think, excuse me, I don't think that's really something to be really concerned about. I do personally think that omega-3 supplements are high quality. Omega-3 marine source supplements are one of the most important supplements for improving health span. I think data is finally starting to catch up on that. I personally, as you guys know, I take Norwegian Pure 3 fish oil supplements. I take the high DHA, and I mix in some of the high EPA as well. That supplement is hard to get. I don't have an affiliation with them other than I'm friends with the maker. But I know that he's got a very, very stringent quality control for purification. And I think that, he's not willing to compromise that. It's hard to kind of mass produce things. A lot of times when you scale up, something's got to give. And oftentimes that's something with respect to fish oil could be the purification and the quality. But there are other fish oil supplements that are good. You can find rankings, third-party rankings of fish oil supplements. Labdoor is a good one. You can find they've assessed the purity, they've assessed the concentration of omega-3 fatty acids in a variety of consumer available fish oil supplements. So I would suggest looking at Labdoor to find a good supplement until the Norwegian Pure 3 supplement is readily available. Right now, it's sort of limited to Norway, and I'm able to get some. But again, you can find a high quality one on Labdoor. Jeffrey asks, I've previously learned that fasting and exercise cause growth hormone secretion, which stimulates muscle growth and fat loss. I've also previously learned from you that IGF-1 and chronic disease, namely cancer, are linked by correlation or causation. The confusion for me is that, as far as I can tell from all the research I've found, growth hormone causes IGF-1 to be secreted by the liver. Is that correct? If so, how can we limit IGF-1 while fasting if growth hormone is increased with fasting? This is a great question. I do think that people that are really savvy in diving into this literature may be confused a little bit. One of the major regulators for growth hormone secretion is stress. And like fasting is a type of stress on the body. Exercise is a type of stress on the body. So those things can increase growth hormone secretion. Growth hormone is a regulator of IGF-1 production in the liver, but it's very minor. One of the major regulators of IGF-1 production is actually food intake, and particularly intake of essential amino acids. Glucose also can regulate the bioavailability of IGF-1 through IGF-1 binding proteins. So what we know about IGF-1 during fasting is that fasting causes IGF-1 levels to drop. Like, that's been measured time and time again. And in fact, the decrease in IGF-1 levels are responsible for many of the benefits of fasting, particularly with respect to the rejuvenation effects. That's been studied by Dr. Walter Longo. And I've covered this many times. We can get into it again some other time. But that's essentially the major thing to consider with respect to fasting and growth hormone IGF-1. All right, last rapid fire question from Justin. Justin says, I've seen that you're aware of the links between heavy metals and turmeric. I was wondering if there's a way to obtain safe turmeric, raw or powdered, or if one should just resort to trying to grow it on their own. Let me explain the issue here with heavy metal contamination, and particularly it's really limited to lead. And also the reason for that is powdered turmeric. So powdered turmeric that is already processed is often contaminated with lead chromate. Lead chromate has a very bright orange color, much like turmeric. And so countries like Bangladesh and even India to some degree, what's found in their processing plants is that because it's cheap, much cheaper to get lead chromate, it's basically adulterated. The turmeric, they add some of that lead chromate to make it look nice and bright and yellow, and it's a cheaper, so they're mixing it with the turmeric and processing it. And so the powders have been, multiple studies have now been shown 100%, Bangladesh sourced. But I've become it seems like everything's coming from India, Bangladesh. And so I have really become extremely skeptical of any powdered source of turmeric. I just don't know where the source is. Getting the turmeric root is not an issue. That's not the issue. You're not going to find lead chromate in the turmeric root. That's the issue is people are getting the roots, processing them, and then adulterating them with the lead chromate because it's cheaper and it has that bright orange color and make it look really nice and pretty. So that's the real problem. I haven't found a solution except for I'm obtaining my turmeric from turmeric root. and cooking with the root, that's so far been my solution. If anyone can find me a source of turmeric that is not from India or Bangladesh, please send it my way and I will share it. But that's basically my take. All right. That's it. Ken is asking in the chat, the company. So the official brand that I take is called Norwegian Pure 3 or N Pure 3. But again, it's not really widely available yet. I know that that's being worked on. But until it becomes more widely available, Labdoor is I've used that ranking service to look at various supplements and stuff, as well as Consumer Lab. Consumer Lab is another one, but Labdoor really specializes on looking at the omega-3 quality. So you can find that. Lydia is asking about Mariva curcumin. So the question, I guess, would be, well, if the turmeric is being adulterated, then what about the curcumin source? I typically get, there's like two brands that I'm really I find to be very reliable. I've known scientists that have tested their supplements before, and it's one of the reasons why I use their brands. Thorne and Pure Encapsulations are really two reliable supplement sources, and so I feel pretty confident. I take the Mariva from Thorne, because I really feel that they're a really reliable source. But yeah, I think Consumer Lab also. I do subscribe to their. It's I forgot how much it is for an annual subscription, but you get access to all their third-party testing, where they go out and they test a variety of curcumin supplements and turmeric powders, and they look for lead contamination as well. Mostly with the supplements and less with the cooking stuff, cooking like powders and stuff. So take a look into Consumer Lab. To kind of see, maybe that would be another way to figure out, I use them for looking at, contamination, cadmium and arsenic with cocoa powders and stuff as well. So I really like using Consumer Lab and also a Labdoor. Again, that's it for today's Crowdcast. It's going to shut off soon. Again, you can find a replay of this Q&A episode on your dashboard, foundmyfitness.com/dashboard, DASHBOARD. And if you haven't already downloaded your private podcast feed, you can also download it from your dashboard, where you can access all your member perks. I hope you guys have checked out the cool aliquots that we released, the one on child development, the sauna one, and the one on fasting, where we kind of took a mashup of all these Q&As over the past couple of years and put them together in interesting mashups. So I hope you guys have listened to those already. I thought they were pretty good. And I look forward to next month's Q&A. Please, so those of you that did submit questions earlier in this comment section here, where I typically use, I look at live, resubmit them on the Ask a Question section at the bottom on the Crowdcast here, because I did see there were some good questions there, and it would be nice to have those resubmitted. You can sign up for the next Crowdcast. Again, we will be sending out an email with a summary of this Q&A. If you do have your private podcast feed, you'll have a timeline there in the private podcast feed, but it also will be emailed out to everyone. So you can kind of skip ahead to certain points that you would like. And that's all I have for you today. I hope everyone has a great weekend. It is a holiday weekend, so Enjoy some fresh air, some sunshine, and some socially distanced outside, whatever it is you're doing. All right, everyone. I will talk to you guys next month. Stay well.